All right, guys, we're ready for section 8.1, which is all about simplifying expressions. So chapter 8 moves into a new topic about solving linear equations. So we know what linear equations look like now from chapter 7. And now we want to look at what does it look like to solve these equations. And before we can solve them, we have to think about how can we simplify these expressions, the expressions with numbers combined with variables and things like that. How can we make those as simplified as possible? So read section 8.1. If you haven't done that, make sure you do that before you continue with this video. But I'm going to try and hit on some more examples like the ones in the book and just hit on some of those main topics, okay, and review those. So the first thing that 8.1 talks about are a couple of different laws that we can use to simplify expressions. So I'm just going to put those into some words that we can understand. So the first one is the commutative law. And I don't expect you guys to remember these laws or memorize them, but I do want you to understand what they mean and what they allow us to do. The commutative law basically means that anytime we add, so addition and multiplication, those two operations specifically, so just these two, it means that when we have addition or multiplication, they can be done in any order. Now, as I'm writing this, I'm realizing by that I don't mean we know multiplication always comes before addition, right? So the first thing we always do is follow PEMDAS and make sure we always carry out all multiplication before addition. But addition itself, any addition, if there's two additions, you can do the second one first or the first one first. Okay, same thing with multiplication. So we're going to use that law today and also the associative law, which I'm realizing right now that I'm spelling wrong. So let me make sure I spell that right. Okay, associative law. And this again applies to just addition and multiplication. Addition again and multiplication. So you can also do this with multiplication separately. Addition and multiplication can be performed. My goodness, I'm having troubles with spelling today, huh? Okay, performed from right to left or left to right. Okay, so just because we see one on the left first doesn't mean we can't do the right one and then come back to the left one. So kind of like commutative law, except for commutative law actually allows us to flip the two around, whereas associative law allows us to think, okay, I don't have to read this like a sentence. If I'm looking at addition or if I'm looking at multiplication, I can do what happens on the right before I do what happens on the left, okay? So let's think about those laws and how they would apply to simplifying these examples. So we're gonna look at some examples and simplify them. So this first one here, I wanna take 9 minus 2x plus 3, and I wanna simplify this expression, okay? So by this, I mean, I have a couple of terms here, right? I know I can take 9 and 3 and combine them. They're both whole numbers. They're both numbers without variables. So in order to combine them, I have to think, okay, well, I can do this in any order I want. And I can also do subtraction just as long as I think about it as plus and minus, right? And take that minus sign with the -2. So I can think about this problem instead as, okay, if I want to take the 9 and 3 and combine them, what am I actually doing? Well, that 9 is positive, that 3 is positive, so 9 plus 3, and I can switch the order of that -2 and 3 by the commutative law. Okay, so I can think about this as 9 plus 3, but I have to make sure I subtract 2x because it has a negative sign on it. And once I see those next to each other, maybe you can more clearly see, okay, then to combine 9 and 3, 9 plus 3, I know that's 12 minus 2x. So I've taken this original expression and I have simplified it by combining those numbers together. Let's try another one here. What if you have -2 times 4x? Now, a lot of the time we'll use parentheses, and we know that, again, by PEMDAS, that anything in parentheses has to happen first. But I can't actually take 4 times x, right? That's already simplified. But what I'm looking at is, oh, I would really like to be able to take this -2 times 4. Well, the associative law, right, says I can do this in either order. I don't necessarily have to do this multiplication before this one. I can do the -2 times 4 first. So I don't have to, by those laws, think about those parentheses at all, since this is all the operation of multiplication. And I can follow that associative law and do the operation on the left before I do that operation on the right that was in parentheses. And that's specifically because the only operation happening in this expression is multiplication. So I can get rid of those parentheses and take -2 times 4 to get -8 and have the x there, and simplify this original expression to be -8x. Let's look at one more here before we move on to another law to help us simplify. The same thing is true for addition. So let's say I have an expression that tells me to take 3 plus 7y first and then add 9. Well, again, because I can do addition in any order that I want, from left to right or flip them around or anything like that, I don't need those parentheses. The only operation here happening is plus. So I can take those parentheses away. That's the same thing as 3 plus 7y plus 9. And I can again change the order due to the commutative law and say, okay, that's the same thing as 3 plus 9 plus 7y, and flip that addition around. Okay, so we kind of use both laws there to solve this one, because now we can see it simplifies. Again, 9 plus 3 is 12, and we've simplified and combined those numbers together. Okay, now here we were able to get rid of the parentheses in both 2 and 3 because the only operation happening was all multiplication or all addition. But we need a new law if we have those two operations happening at once. So we have one other law we want to talk about here called the distributive law. This is probably the one you're actually going to think about as an actual law. We distribute a lot of the time to simplify expressions. So this is the one you kind of almost always remember the name of this law. And that's when we have something, when we have the two operations combined. So if I have, A plus A times B plus C. So I cannot just get rid of those parentheses because one of these operations is addition and one of them is multiplication. So I have to, according to the order of operations, do anything in the parentheses first. But again, B plus C, I can't combine those, but I would like to remove the parentheses if I can. So it turns out if I distribute this A, if I take the A times the B and the A times the C, distributing to become A times B plus A times C, I can get rid of those parentheses by distributing. And I can do it with negatives as well. So remember, I can think of addition as just, subtraction is just subtracting, adding a negative, right? So if I have a negative, this still works. I can still distribute the A through, and that time then I'll just end up with A times B minus A times C for my distributive law. So it's another way to get things that are trapped inside parentheses that can't be combined outside of those parentheses to simplify the expression. Okay, so let's look at some examples again. And our goal again is just to simplify, combine all the terms that we possibly can, all those whole numbers we see. Okay, so the first one here will be to take -2 times x plus 5. So again, on the inside of those parentheses, I don't know what x plus 5 is, and I can't simplify that. But I can carry out this multiplication and get rid of those parentheses by distributing. So my final answer here should be -2 times x plus -2 times 5, and that equals -2x plus -10, or -2x minus 10 in the most simplified form. Okay, so we can distribute any number on the outside that needs to be multiplied through some parentheses where it's saying addition should happen first. That addition is still happening first so long as I go ahead and distribute. Okay, let's try another one here. Let's throw in a fraction here to show you how that works out. So I can take also any fraction outside times anything on the inside. So 3x plus 4y here. These two terms cannot be combined, but I can take that 2/3 through the parentheses. That would be 2/3 times 3x plus 2/3 times 4y. And now I can take those numbers and multiply them together. You can do that in your calculator or remembering how to multiply fractions. You'll see here with the first one, the 3's will cancel and we'll actually just end up with 2x. And here with the 2/3 times 4, nothing will cancel and we'll end up with 8/3 y. Now those cannot be combined, and I have simplified this original multiplication by getting rid of the parentheses using distribution. I just want to run through a few more examples of this, okay? It seems like there's kind of just some different ways to look at these problems. So here's another one that sometimes will trip students up. If we see that multiplication happening on the other side of the parentheses. Now, it's very typical that we'll instead see that multiplication out front because remember, multiplication can be done in either order. It's commutative. So we can switch this around. We can just think of it in the way that we have been looking at the other ones. And it works just the same. That 4 can distribute through. Or you can think back here without switching it around as if 4 distributing through as well. Either way, you should end up with 4x minus 4 times 3z. And again, because this is all multiplication on the last term there, we can take the 4 times 3 outside of those parentheses and get minus 12z there. Okay, and so that's the most simplified version. It has no parentheses. Another one that tends to come up is when you have a negative on the outside of the parentheses. So it looks like you're not seeing a number there. So negative 5x minus 6y. Again, you still here cannot drop the parentheses. We need to take essentially that negative through. Think about that out front as being a -1 that you're taking through the parentheses. And that just changes all the signs. -1 times 5x is -5x. -1 times -6y, that's minus a -6y. Okay, it makes that 6y positive in the end. So we end up with -5x plus 6y. It's changed both the signs of the things on the inside. So make sure, the biggest mistake I see there is that you forget to take the negative to that second term. The negative goes to everything, not just the first term. Okay, so kind of star that one for yourself to remember that that's kind of a common one that'll come up and possibly be a common error you might make. Okay, the other thing I want to point out, last thing I want to point out with the distributive law is you can distribute through several operations on the inside. Here, this one has 3. That's all right. It just means that whatever is being multiplied on the outside goes to absolutely everything on the inside. So here we would end up with 2 times x plus 2 times 2y, which would give us 4y, minus 2 times 3, which would be minus 6. None of those things can be combined, so we're done right there. Now I do want to point something out, right? I keep saying, I get to a point where I say none of these things can be combined. Well, why can none of these things be combined? It's because they're not like terms. I can in no way say 2x plus 4y is something else, okay? So we call these things like terms. So I just want to point that out. Combining like terms. What does this mean to be a like term? So if things are like terms, then they have the same variable, kind of like having the same unit, and, the same variable that is raised to the same exponent. So just to give you a couple examples here, okay? So if I have 4x, I could combine that with 6x, something like that, or with -2x. All of these things are like terms. If I instead have 4x squared though, then I could combine that with 6x squared or -2x squared. But these separately are not like terms. because even though they both have x's, those x's are not to the same exponents. So make sure you understand like variables, things that can be combined are same variables to same exponents. So we want to get a little practice on what does it actually look like then to combine some of those like terms, because so far we've only combined numbers. So let's look at some expressions where we have to take that step of combining like terms. Okay, so again here we're going to simplify as far as we can. There we go. So far we haven't combined anything with variables yet. So the first one we want to look at here, let's look at 4x plus 7x plus 2 plus 3. Now from before, we realized, okay, we can take that 2 plus 3 and simplify this, but we can also take 4x plus 7x. Those both have the same variable x to the same exponent of 1. To combine them, just think of x like a unit. I have 4 x's and then I need to add 7 more x's. That gives me a total of 4 plus 7 or 11x, and 2 plus 3 is 6. So I have combined my like terms and simplified this expression down. And this is really where we are to start to see that simplifying, actually making that expression smaller and more simplified, not just necessarily getting rid of parentheses. Okay, so try this one as well. Sometimes you won't see those like terms next to each other, and that's okay. We know that we can do these things in other orders just so long as we keep track of the signs, right? So this is the same thing as 8x. Make sure you take that negative with the 5. Minus 5x, then we have minus 3 plus 1. So we switched this order around, but we made sure we kept track of the signs. And now we can say, okay, I can combine like terms again. I can take 8 minus 5 to get 3x, and I can take negative 3 plus 1 to get negative 2, and have a simplified version of my original equation, which was much longer and more complicated. Okay? So you really start to see how this simplifying comes together as we combine these two steps that we've been working on. So what we really want to do now is look at some more complicated examples and really see how to simplify an expression. So I do want to give you a couple of steps here. So in order to simplify an expression, we've kind of gone through two different steps here, and you want to do them in the order that we just did. So to simplify an expression, the first thing you want to do is remove all those parentheses. That's why we worked on those first few, to understand when we can just drop them and when we have to use the distributive law to get rid of them. Okay, the first thing you're going to do is remove all parentheses by applying those laws that we looked at. Then once you have no parentheses, you have all those terms outside of parentheses, that's when you're going to be able to combine like terms and simplify that expression down as far as it'll go. Okay, so let's look at some bigger examples here. So can you simplify this expression? Negative 2 times x plus 5y plus 3 times 2x plus 4y. So this is why we have to get rid of the parentheses first, because I see some like terms, but I can't combine them because they're in separate sets of parentheses. So I need to get rid of the parentheses so that I can start to do the addition in whatever order I would like. So the first thing I'm going to do is get rid of my first set of parentheses by distributing the negative 2. Anytime you see negatives, make sure you keep track of signs. So we have negative 2x minus 10y by taking the negative 2 times x, and then the negative 2 times 5 to get negative 10. Bring down all of your signs, plus. Then this 3 gets distributed through the inside. Plus 3 times a positive 2x gives us a positive 6x. 3 times a positive 4y gives us a positive 12y from taking the 3 times the 4. Okay? Don't lose any of your signs there. Now, again, we can start thinking about, okay, I see some like terms. I see some x's here, I see some y's here, and I want to think about combining them. And you might be at the step where you can already think, okay, I see this is -2 plus 6, and combine those to be 4. But if you don't see that, go ahead and switch the order around first. So we have -2x plus 6x, bring the sign with it, minus 10y, bring the sign with it again, plus 12y. We can switch those two inner terms around in order to see those like terms next to each other now, possibly making it easier if you couldn't see that before, that this is -2 plus 6. -2 plus 6 is 4x. -10 plus 12 is a positive 2y. So don't write that sign down until you know after you've done the addition or subtraction whether or not that term should be positive or negative. And that's your final answer there. Okay, let's do another one. So this one, let's take 5 times 6x minus 1 plus 4x. So we've got the 4x on the outside of the parentheses. We'd like to combine that with that other x term we see, but before we can do that, we need to know what the exact x term is. We need to take out and do that distribution, okay? 5 times 6 is 30x. 5 times -1 is -5. We still have that plus 4x there. Again, if you can see it right now, go ahead and combine 30 plus 4. If you can't, switch this operation around right here. 30x, the 4x is positive, so it will stay positive, and the 5 is negative, so it will stay negative. Then you can see this combination here, 30 plus 4 is 34x minus 5, and we have the final answer. Again, you might need this step or you might not, but just make sure you're understanding always to go with the side right in front of whatever you're combining it with. Okay, you'll get lots of good practice on doing these in the homework. Okay, so hopefully that just gave you a few more examples of ones to help you out. The other thing I want to look at here today is the other topic you see in this section, which is translating essentially from English to math and math to English, okay? We've done this a little bit. Let me get this written down before I continue because I can't write and say things at the same time apparently. So translating from math to English and back and forth, okay? So if you remember, all the way back in chapter 1, we had a whole list of things like that product meant to multiply, quotient meant to divide, and all those types of things, okay? But what we didn't have was this variable in play. So we want to see how that variable is kind of said when we're speaking about these expressions and trying to think about them in terms of examples and things like that, okay, like real life examples. So translating from math to English and back and forth, okay? So the first thing I want to do is go from English into math, okay? So we want to translate these words into an expression we would be able to simplify, okay? That's often what we're doing with word problems, right? We're taking a word problem and trying to translate it into an expression so that we can do the math with it and understand it in a little bit simpler view. So the first example I want to work on here is to take 3 times a number minus 4 plus twice the number. So take this one word at a time. We're going to translate this to an expression and simplify it. 3 times means 3 multiplied, okay? And this is where you start to see the variable. 3 times a number. We don't know what the number is. That's often what we'll use for x. You could use any variable there though. Minus 4. Minus 4 plus twice is 2 times something, right? That's what twice means, the number. So it's the same number we were talking about before, so twice the number, which we called x. Looking at that, that's 3x minus 4 plus 2x. And I can simplify this expression. I've got 3x plus 2x minus 4, and that is 5x minus 4. So I've translated the expression and simplified it. Let's look at one other one. This one gets a little bit complicated because it's going to give us an example of how we would say something where parentheses are involved. And it's not going to say parentheses, so we need to understand how that looks. So here's an example. The number plus 3 times the difference of the number and 7. So now we know when we start to see a number or the number, that's what we're doing to represent a variable, right? So we've got the number, we're going to name it x again, plus 3 times something, plus 3 times, and here you go. This is where you start to see parentheses coming into play. I have times the difference. I have two operations listed right next to each other. So times, and I'm going to subtract something, and I need to multiply by that entire difference, so that's when I'm going to have parentheses. And I'm going to find the difference of the number and 7. And that's how we'll know parentheses need to be used. The key is when you have two operations said with no numbers in between them. Okay? Now I can simplify this expression. That's x plus 3x minus 21, and x plus 3x is 4x, and I carry down that net minus 21. And we've got our expression here that's been simplified here. Okay, so here's a good test. Can you take that information and now go the other way around? So we're going to go here now from math into the English phrase. Okay, so can you take x minus 5 times x plus 2 and say that in an English phrase? So let's see, anytime we saw x, it was a number, right? So this time we've got a number, then we see a subtraction sign, so minus, then I see a 5, so minus 5, and then I see an operation, 5 times, and remember, in order to get from those parentheses, I need a new operation, so 5 times, and then what's that operation? Times the sum was a good way to say addition, times the sum of what? Of the number I mentioned before, plus 2. Okay, again, you'll get good practice with this in the homework, but I kind of wanted to break that down step by step. Let's try one more. This time I'm going to throw in a division, just so we can remember how to say division. Okay, so this time again, I've got 3. I see 3 first, so I'm going to write 3. It's being multiplied, so times is a good way to say that. 3 times, actually, let's go with a different way to say that too. That would work perfectly fine, but I see a product, right? This is just a product right here. So I could also say the product of 3 and a number. Okay, that takes care of 3x. Then I see a plus, so I could say plus. Then I see division. That's where I would say the quotient. And always list the numerator first, the quotient of 6 and x. And then I see a minus sign, so minus, whoops, make sure you spell it right, minus 3. Goodness. There you go. Okay, so hopefully those examples will help you with the homework. Reach out to me if you have any questions, okay? You'll get more practice on the activity too.